Hi, welcome to everyone's favourite segment, Mailbag, where I open my mail. Start off with a biggie. This one's huge. It weighs about 20 kilos or something. Unbelievable. Luckily, it's only local because it cost a fortune to send this in overseas. This only costs like $10 to send locally. It's from El Zhong, if I'm pronouncing that correctly. Probably not. He's from Randwick here in Sydney. So let's open it. Thank you very much, El. So let's crack this baby open. And what do we got? We have, I think we've got some old vintage PC stuff. We've got a 5 1/4 inch floppy. There we go. And we've got 3 1/2 inch floppy. We've got a power cord. Not approved. Hasn't got the new installation on the pins. Totally illegal in this country now to import a power cord. They're very strict on it apparently. Hey, here we go. So he still doesn't say who he is. Just L. Thank you very much, L. Oh. Okay. Let's have a look. I won't tell you what it is. Hang on. This is ridiculous. It's coming. Trust me. Wait for it. It is a Vectorscope. Check it out. And this will definitely be more than a 2-minute teardown, I'm sure. So I'll save this one. Thank you very much, L. If you don't know what a Vectorscope is, this is a PAL Vectorscope for video signals. I actually used Vectorscopes in my first job back in 1989, I think. 1989, when I was working on video stuff. And therefore, calibrating, aligning, checking, doing everything else on PAL video signals to get the video signal right. And, well, maybe, I don't know if it works, maybe we can power it up and have a look at an old school PAL video signal. Now it's all bloody HDMI and all that digital rubbish, but back in the day, yep, PAL composite signal. I'm sure we can still find a PAL composite signal around the lab here. You may not be able to see that, but here we go. This is a Tektronix 521A PAL Vectorscope. And yes, it does NTSC for you Yanks there. But this is designed to measure video signals, all the complex requirements of video signals. A Vectorscope is what you use. Now, these were essential test gear for anyone working with any sort of video signals. My first job was working with video security equipment, slow scan TV and stuff like that. And, of course, we had to actually check out and diagnose video signals. And this is how you do it. And this is actually classic. Check out this screen here. They've actually drawn on here in permanent marker, drawn on here the actual waveform that the video waveform that they required. It's like an on-screen template to see that, it matched. And that was actually quite common. If this Vectorscope was obviously used for like one purpose and just measuring, like displaying that video signal and getting it, and they had to, align, check that it was in, it's not really like a template as in like a pass-fail kind of template, but it's interesting that they've put that on there so that they can see, and instantly you plug in your signal. Does it match what we've drawn in? So they would have had a reference signal, fed in their reference signal, and then drawn over the top of that, and then they feed in their signal under test from the product that they're testing, and bingo, see if it matches. Too easy. Now I've had to turn up the gain on the camera here to actually show you the graticule inside here, but you can see that it's a circular graticule like this. Now this model, it was obviously capable of like displaying a video waveform, because if you're familiar with a PAL video waveform, that's like a typical video, what a typical video signal might look like with a stepped, like a bar type waveform or whatever it is. But what Vectorscopes are really for is they use one of these circular type displays, and it's plotting, it's basically an XY plot of the chrominance information, and so the color encoding information on the video signal, and from the phases of everything like that, you can actually determine a lot about, well, everything about the video signal from the XY chrominance difference information between two different signals. So you might be able to see various little portions of the graticule down here have these little target boxes on them, and what you do is you'd actually plug in typically a bar graph, a bar signal, a bar test signal, a color bar test signal, and then your display would actually have several points in here. I'll have to overlay a typical signal on there. I'll see if I can find one, but it'd overlay in these points, and you could see whether or not it was, out of phase and not adjusted correctly and everything else. So if it was in these target areas, you knew that your signal was good and everything was aligned correctly and all your amplifiers were properly adjusted and things like that. And we've got ourselves some secret squirrel adjustments under here, like your beam rotation, your vertical clamp and your horizontal clamp, things like that, and then all your focus and differential, what your differential phase is doing, and all sorts of weird and wacky stuff. But yeah, you'd have to go into the intricacies of how color video signals work to understand all of this sort of stuff. But you can select the lines that you wanted to use and your calibration phase, and over here you can swap your fields and things like that, and quite sort of complicated beast to drive. You've got to really know what you're doing and how your video signals work. All right, let's pop the hood on this baby. I've never seen inside one of these Tektronix, this particular model, so it'll be interesting to see. I don't even know what the vintage is. Late 70s. I have to give it a smell test, but it's got these quarter turn screws on the top, and ta-da! Woohoo! Oh yeah, hang on. Oh yeah, that's got mid 70s written all over it. 1967! Jeez, that was before we landed on the moon. Unbelievable. But that's just the copyright on the PCB. This thing could have been manufactured in the 70s. These did have a pretty big service life, I think. We found a date code on this Motorola metal can package, 1981, 25th week. So right there, we've got a pretty darn long lifespan. So here we go. I won't do a full teardown of this, of course. It's just a 2-minute job. But look at all the loom-in. Look at that. It's all tied in place. You can actually see the ties on the looms. Look at that, and it's all stiff and wide in place. Absolutely beautiful. And they all then just pop out of the wiring harness at the correct point, go onto their little terminal on the board, and Bob's your uncle. It's just it's beautiful, beautiful construction. Takes forever, of course. It's like there's a lot of work that goes into producing these. It's not cheap. It's not easy, and some people say, well, it's not even elegant by today's, sort of modern production standards and things like that. And it's not. It takes a lot of effort. You wouldn't do something like this today with all these cable looms and things like that. It's just, really old school stuff. And for those playing along at home, here's the back of the thing. We've got our CRT cover on here, and our old school transistor covers, our TO3 packages. Well, that's a TO3 package. That's a smaller one under there, and using the chassis as a heatsink. Beautiful. We've got all our inputs and outputs on the back here, and astigmatism, geometry, all that fantastic stuff you needed for CRTs back in the days. Of course, you wouldn't use CRTs these days if you had a modern vectorscope. Does anyone actually make a modern vectorscope? Maybe they do. All right, this is scary. I'm going to power it up. We have a green light. Green light's good. Come on. You can do it. Scale illumination. No. Intensity. No. No. Oh. Wah, 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 wah. Well, our intensity's all the way up. Our scale illumination should just be like a light bulb on the outside that just, lights up the lights up the scale, so it can't even do that. So, yeah. So, thank you very much, L. Jung, if I'm pronouncing that correctly. He doesn't have a first name, he's just L. That could be his real first name. Could be one letter. Who knows? Anyway, thank you very much for sending in this interesting beast. Maybe we can do a more interesting teardown. I'll try and figure out why the damn thing is not doing anything. Anyway, awesome. And no, I haven't changed, but we have someone guessed mailbag opener. Take it away.
Hello there, I'm Ryan Tillotson. You probably have no idea who I am. Well, yeah, pretty much. But I am in here for work experience. No, I will not tell you the name of the school, otherwise they may get angry at me. But yeah, I'll be helping out David with his mailbagging today. And we got this package here, so let's give it an open.
And you know nothing about engineering, you're here for video blogging.
Yes, I am. I want to be a YouTuber myself, and and apparently when David Jones said, yeah, he can come along, he can learn a bit, boy was I excited. So, yeah.
Alright, well, let's open a mailbag item.
Let's do it.
Go for it. You can use a knife if you like.
Love it.
Imagine the OH&S problems here, folks. I don't want to know. Let's just hope the school doesn't see this.
Let's see. Oh, what's this? Whoa. David, do tell me, what is this thing?
Show us. It's a Fluke one-touch network assistant. One of those for those network geeks.
Ooh.
For testing networks. See, you plug your RJ, you plug your Ethernet in the top, and it, yeah.
Very useful. Yeah, I think it's from Samuel Pitches.
Thank you very much, Samuel. Is there any backstory to it?
Let's see. One for teardown Tuesday. Nothing wrong with main unit as far as I can see. Just the battery pack is a bit worn out, and the charging port seems to be a bit flaky. We can work around that. Love the show and watch every episode, and so using those fixings. If you're ever down in the world's most livable city, please let me know, as it'd be great to say hi in person, of course. All the best, Samuel.
Oh, he's not from bloody Melbourne, is he? Yes,
Yeah,
got a world's most... Yeah, he's rubbing it in. Unbelievable. Australia was the world's most livable city at one point, and now it's bloody Melbourne. Yeah, we hate the Melbourners.
Yes.
Yeah.
City all the way! We've got 2 landmarks! Ugh.
So Samuel has sent in this Fluke One-Touch 10100 Network Assistant. Obviously got some whiz-bang graphical LCD on it. Whether or not it's colour, I don't know. And, ta-da, check it out. Requires tongue at the right angle. Center negative. Center negative! Center negative pin. Oh, that's just evil. Isn't it, Ryan? Evil. Yep, Ryan agrees, even though he has no idea what I'm talking about. Still, it's evil. Trust me. Yes. And it comes from VACT, whoever the hell they are, and their asset register. And, yeah, it's just one of these network things. You plug it in and you can diagnose your network and all that sort of stuff. Is that just some sort of RS-232 diagnostic port? I don't know about my network engineering. I'm sure those out there in the know will be screaming at me, and... there you go, plus minus, and 9 volts-ish. Alright, I've got 9 volts going in this puppy. It's showing like 1 milliamp on standby. It's probably not. It's rounded. Oh, excuse you. And power button down, defaults restored. Yeah, okay, thank you very much. It does actually work. Animation. Oh, what happened there? And there we go. We're into the main menus and all that sort of stuff. And network health. All that sort of jazz. Oh, there you go. I could plug that into my network here if I wanted to. Except when the bloody probes fall off. Yeah. And quick 2-minute teardown. We're in like Flynn. Check out the nickel screening on that. That'll be conductive, of course. Check that out. There we go. Yep. And we've got double-sided load on there. And the components, both sides, looks very... professional and high quality. as you'd expect from, well, it's Fluke Networks, which is not Fluke Instruments, so totally different company. No surprises for finding a separate isolation board for your Ethernet here with all your isolators and stuff like that. There's some relays. I think we heard some relays click before, so it's going to have all sorts of, you know, overload and safety and meet all sorts of whiz-bang standards, whatever the standards are for network connections and things like that. And well, yeah, so that's going to be pretty ordinary. What processor does it use down in there? Let's take a quick squiz. There we go. Nice little board-to-board interconnect there. There's the main board. It's got network-specific chipsets and things like that. I won't even bother looking those up. Those playing along at home can do that. Lots of discrete transistors down here, or they diodes for some sort of protection, maybe. I don't know, but that's separate. And this board here just sits in there. Ah, there we go. We've got a nice 0.1-inch header, which goes down to our display board, and we're in like Flynn. Analog devices, DSP. Here it is. There we go. That's the ADSP 2181. So they've got some DSPs. We've got a Xilinx CPLD in there. We've got two of those. Are they the same? 3164s. Yep. We've got ourselves a big unpopulated connector here. That's absolutely massive. That might have been a development connector, or maybe it's for a different model. Perhaps, I don't know, but it's on the top side here, so it would have, maybe it's, you know, a different interface to, instead of that one. I don't know. My best guess there would be that's some sort of development test connector, something like that. Does anyone else think this board might have been auto-routed? Perhaps. It just looks kind of auto-router-ish to me. Aha, we actually have a PC-compatible processor. This is the AMD AM188. This is an 80C188 compatible processor, i.e. 8088 IBM PC compatible. Or Intel, you know, everyone associates it with the IBM, of course, but yeah, there you go. So that's running all the main code and interface and everything else on the LCD and all that sort of stuff, so software development would be pretty easy. But obviously they're doing all the real-time networking stuff, obviously not fast enough to do it in the main CPU here, so they've got to do it inside the DSP. And well, there's not much more to say about that. I see a JTAG programming header there, and that's about it. I don't think the 80188 has a JTAG interface, so that would be for the analog devices one. So yeah, maybe that's what they've got the this in-system development connector for, is for the 80188. Perhaps, I don't know. Anyway, just a couple of FPGAs and a 80188 processor and a DSP doing all the heavy lifting on that puppy. And of course we've got some power supply stuff around here, and Bob's your uncle. Excellent. Thank you very much, Samuel, for sending that one in. Interesting. I might actually have to try and hook that up to my network and see what it says. And here I was trying to figure out why this case wouldn't go back together. Yeah, can you figure it out? Oh! Actually, I rather like this design. It's incredibly simplistic how it goes together, and the screws from the outside screw into here and hold the boards in. So there's only these two internal screws, and that's it, apart from the LCD display board. I just like the simplicity of that. It's very well designed.
And so, next up we have one from California, US, from someone named Donald B. Botkin. So, let's take a look. Maybe going a bit through the box here. Alright. Don't worry, I know how to use knives, I swear. Let's see. Oh, it's a dinosaur. Oh, look at that. It's a little robotic dinosaur.
Naked.
Yeah. Oh, wow. Apparently this one lost all its fur. Well, it's still got some with some sponge. Okay, that's cute. Oh, wow. Thanks, Donald. You certainly know what David likes.
Possibly what Sega likes.
Yeah, I can just see this in a Sega game. Yeah, I think that's rubber that the head's made out of. And, oh, look at that. I think its eyes still move.
Animatronic eyes.
Doesn't say, apparently it doesn't work anymore, though. But, hey, it's the presentation that makes it all good.
So thank you very much, Donald. This is fascinating. Roar. It's an animatronic dinosaur, and he was built by a startup company called EEVblog. That was right across from street from Research Advantage, which is where Donald works, and apparently we can get this puppy going. Yeah. Wow, it's got a USB port,
and his mouth opens. Yeah, you just need to kind of force it open.
Cool.
Roar.
Very timely with the new Jurassic Park, which I haven't seen yet. Have you seen the new Jurassic Park?
No, I'm not much of a movie person.
No?
Yeah.
Okay.
It's pretty cool.
Right. Because I think the first Jurassic Park would have come out before you were born. Maybe not. Oh, when was the first Jurassic Park?
I don't know. I'd have to look it up.
I don't know. But, yeah, that's very cool. That looks like a very complicated beast. Wow. There's a lot of stuff that goes into that. That's fantastic. And apparently, we might be able to get it going. 7.2 volts, that would imply it's got a rechargeable packing there of some description. Awesome. Too bad all its skin's gone, but it's nice that we can actually see it and it's torn down. Very cool. It's got, there's an SD card slot on the bottom. Donald talks about an OS or something, USB port, and little sensor pads for the feet. So it knows when it goes down like that, and it can twist its body and its tail and all sorts of jazz. And you notice a speaker on there, so
yeah, it's definitely got to have sound. Like
it's got to go.
Yeah.
And animatronic eyes. That's terrific. But they folded. It was done in 2007 by a startup company, and they folded in 2009 apparently. So yeah, I guess nobody bought animatronic Dino. Oh, sad face. So here it is. Isn't it cute? Oh, Donald, this is like one of the best mailbag items ever. It's so cute. I want like a proper one with the skin and everything. It turns out this is the Pleo. That's his name, Pleo. And this is an animatronic dinosaur, as he said, developed by a company called EEVblog back in 2006, and it was released in 2007, and for about $350 and sold a whole bunch of them. Like they sold out within days or something, like a couple of days. The first couple of thousand sold out, and they ultimately sold 100,000 of these things. And I can't say that I've ever heard of it. Maybe I did see it back at the day and, went, oh, okay, it's an animatronic dinosaur. But it's now I've got kids, I understand, that something like this is fantastic. And you'll notice that, there we go, there's his camera in there. He's got all these sensors. They look like infrared transmitter and receiver in there. And he's got operating eyes and mouth. And he can actually sense things that you put in his mouth. And the whole idea behind Pleo, oh, his battery, his guts fell out. Whole idea behind Pleo is that, like, he goes through these different stages of development. Like he's just like, when you first get him, he's programmed to be like a newborn. And then he goes through like a 5-hour process of being like a newborn dinosaur where you teach him to open his eyes, you stroke him, and, he's got all these sensors on him that allow you to interact with him. And as I said, sensors on the feet, and he can recognize when you touch his feet and things like that. So he lift up his, his paw. That's not the correct, his foot. Dinosaurs don't have paws. Anyway, here's some footage. I'll put in some footage of him actually operating Pleo, and he's just so cute. And this is nude Pleo. This is without all his skin. Anyway, apparently the company went bust or whatever around about like after they shipped him, and then another company came in, and now it's the Pleo RB. And apparently, I think you can still get him, or the website's still there, and you can get all sorts of accessories and all sorts of things. Anyway, yeah, he's designed to go through like a learning stage, and then he learns to walk and all sorts of things. So, really, it's just fantastic and so cute. I'm going to have to get myself one with like the proper one with the skin on and everything. Sagan had just go ape over this.
So I picked a Camarasaurus because the Camarasaurus was the most abundant of the sauropods in North America, and you could actually find full fossil evidence of these. That's a juvenile. And so we actually went in. There's a book called Walking on Eggshells where they found actual sauropod skin in Patagonia. And the picture from the book, so when I told the sculptor, use this bump pattern, whatever you can to copy that. So there's the motor. And about this time, all these other people are starting to help. Here's an example of what we did with the skull. There's the skull. There's my drawing of a skull. There's kind of the skin version of the soft tissue. There's the mechanism that would go in there, kind of a Geneva drive. There's some SolidWorks versions of it. Here's some SLA parts of the same thing. And then these are really crude pieces. We were just doing some tests here. And there's kind of the first exploded view or see-through view. There's the first SLA version. And it already kind of has the feel. It has kind of a cuteness already. And the thing about blending science and art and this multidisciplinary stuff is you can do a robot, then you go back and do the shape, and then you go back and forth. The servos and the front legs, we had to shape those like muscles. They had to fit within the envelope. There was a tremendous amount of work to get all that working right. All the neck and the tail are cable, so it moves smoothly and organically. And then, of course, you're not done yet. You have to get the look for the skin. The skin's a whole nother thing, probably the hardest part. So you hire artists, and you try to get the look and feel of the character. Now we're character designers, right? And then, 4 years and $10 million later, we have our little Pleo. These are little Pleos, and you can probably see them. This on purpose. They go through life stages. So when you first get them, they're babies, and the more you have them, kind of the older they get, and they kind of learn through their behavior. So this guy's listening to my voice here, but they have 40 sensors all over their body. They have 7 processors. They have 14 motors. They have but you don't care, do you? They're just cute, right? That's the idea. That's the idea. Okay, he's hungry. I'll show you what he's been doing for 4 years. Here. Have some money, Pleo. There you go. That's what the investors think. That is just. So they're really sweet little guys, and we're hoping that our belief is that humans need to feel empathy towards things in order to be more human, and we think we can help that out by having little creatures that you can love. Now, these are not robots, they're kind of love bots, they do change over time, but mostly they evoke a feeling of caring.
Okay, Pleo, here we go. Oh, that was on. Oh, it helps if I turn my damn power supply on. Here we go. Oh, I heard something. A little peep from the speaker. Come on, Pleo. Come on.
What?
Oh!
It's alive. Is it? Come on. You there? Come on.
He's drawing 1.2 watts.
Oh.
Hello?
Oh. Come on, Cleo. Come on.
Come on, Pleo. Come on.
Oh. He's so sleepy.
And he's obviously, look, these sensor pads on the top, these are capacitive, these look like capacitive pads. So, like, when you pat him, then he obviously recognizes these, when you touch his, because they're shielding, once again, around the legs here. And he's doing something, although Donald said he might need an operating system upgrade. Oh, come on.
Poor thing.
Come on, Pleo. His legs are up. His eyes are open.
Come on, Cleo. Oh. Oh. Oh, it's okay. It's okay. Oh. I think he's scared. Here. Oh. That is cool. Oh, he's tired.
gone to sleep again.
Well, we know it's alive. It's alive. It's adorably alive.
Oh. Oh.
Poor thing.
So that's a key. You got to pick him up, and he wakes up, and then he obviously goes into like a sleep routine. Oh, he's going to pull his own power cord out. See, he goes to sleep, and then you pick him up, and he'll he wakes up. Go Pleo. Oh.
He's so sleepy.
So yeah, obviously that's a capacitive sensor touchpad. So when you go pat him, it can detect that you're trying to pat him. There's, most probably a accelerometer in there, of course, a tilt when he's tipped over and things like that. And as I said, little sensor pads on his feet, they might help him walk, or maybe I've seen like videos of people like touch his foot, just like lightly touch it. So there's another capacitive sensor in there, although this one around here has to be, there's no other reason, there's no shielding reason for that really. So it's got to be a capacitive touch sensor again. And yeah, and it's got USB camera. So like I've actually seen a video where he actually walks towards the edge like this and knows that he's going to go over the edge, and he sort of goes and sort of backs off a bit from the edge. So there's a lot of sensor and firmware intelligence which goes into this, and all the articulating mechanisms. That's quite nice. There's his rubber skin. This one's obviously just been hacked off completely. Whether or not this is a prototype, or whether or not this is a production unit, I don't think Donald says in his letter. No, I'm not sure. But yeah, I mean, it looks fairly production, what you'd get inside a production unit, I suspect. So there you go. So cute. Pleo. Say bye-bye. And I think he's got some maybe infrared sensors in his mouth there, because he apparently comes with some sort of leaf or something. You train him to eat and all sorts of stuff. Brilliant. So thank you very much, Donald. That is quite possibly the coolest thing I've ever had on Mailbag, and I so want to tear him down, but it doesn't look particularly easy. Well, it's always easy to tear down. It's never easy to put them back together in working condition. This battery pack's interesting. I originally thought AA's go in there, but I don't think so based on that configuration there. And then the springs at the bottom, and that just goes in there like that, and then that clips in there. That's rather quite neat. But yeah, apparently you can still buy the battery packs for them. I'm not sure, like the new one is supposed to have all new experiences, and the Pleo RB is supposed to have all new, mostly probably just firmware upgrades really, as opposed to it's probably still the original hardware platform, I suspect. But anyway, if anyone knows any more details, then that is fascinating. I want to do more videos on Pleo. That's just awesome. Thanks, Donald. Sagan's going to love it. All right, Ryan, let's check this one out. This one's anonymous. Where does it come from? Oh, bloody Melbourne again. Bloody Melbourne. We hate Melbourne, don't we? Yeah.
Melbournes have all the fun.
All right. They get all the events.
Yeah, all the excitement on YouTube.
Actually, Melbourne have a really big YouTube community. Do you know that? We got nothing here in Sydney, but Melbourners get together all the time. All these Melbourne YouTubers, and yeah, they have tons of events.
In my opinion, Australia needs more YouTubers in general.
Ooh, what do we got? Ooh. I was going through a box of assorted manuals I scored a long time ago, and we have a whole bunch of manuals. Thank you very much, John. John sent them. And he found quite a few duplicates. What's that one?
The 6034A User's Guide.
For HP.
HP.
Before HP became Agilent, and then they became Keysight. And we hate Keysight, don't we, Ryan? Yeah, it's just, no, the name's hopeless. And we have a system, 6034 system DC power supply, complete with pornographic fold-out schematics. Oh, wow, look at that.
Oh.
Wow, isn't that beautiful? Oh. So John is kind of sending in all these old HP manuals and stuff. Terrific. Meet the 6034A. Yeah, it's your new friend, the 6034A. Then we've got the matching service manual for this, the operating and service manual. And as I said, just, yeah, pornographic fold-outs of all the circuits. Fantastic stuff. Love it. And all the board overlays and the bill of materials and everything else. Terrific. Fantastic. They spared no expense. People don't do manuals like these anymore. Oh, the 1700 series analog scope with the multimeter attachment on top. Oh, that was the duck's guts back in the day. I'll tell you what. I'll tell you that for nothing. And there's our power supply. You can tell that's a power supply just based on the topology. There's our series pass transistor up there, and and you've got the regulator servo happening there. You've got some feedback stuff happening, and Bob's your uncle. Of course, before the internet, right? Yes, I've been telling him all about it. I've been showing him my data books here before the internet and PDFs came along, right?
I'm a whippersnapper.
Young whippersnapper. So we've got our application notes. This is where you found all your information, and you've got to eliminate time-based errors from your oscilloscope measurements, because back in the day it was, none of this crystal oscillator time-based rubbish. No, they'd have, an RC oscillator probably in the old HP scopes. And we've got our service manual for the 1727. Oh, look at that. Look at that. Wow. Unbelievable. Oh, it's all happening. And wow. Like, they'd actually be hard to scan in because they're so big and long and complicated. And that's looks like part of a system wiring diagram there. And whoosh, wow. It's just chock full. Look at that. That's just all service information line. Look at the billet. Look at the beautiful diagrams, the exploded assembly diagram views which they did back in the day. Someone actually drew that, You have a draftsman back then. It's not a draftsperson. You had a draftsman back then. It might have been a woman, but they were called draftsmen, and they didn't complain about it. And there's all the front panel controls. And it's just, beautiful. And the universal counter, once again, operating and service manuals. These are worth their weight in gold. They really are. If you're looking to buy secondhand gear on eBay, and just check to see if the service manual's available. Fantastic. Oh, look, we've got some diff pairs happening in there and all sorts of... Whoop. How do I put that back together? It's like folding one of those maps. Have you ever tried to fold a topographic map? There's a certain way you've got to do it. Certain art to folding those. Brilliant. Awesome. Thanks, John. And we've got the operating manual as well. Fantastic. Terrific stuff. Next up, we have one from Jacob with a K. Jacob Steno. He's from the old Dart, the UK. And let's check out what he sent. Oh, it's a bit weird here with a second person with the knife. I don't know where to point the knife. I don't want to... Imagine the paperwork if I stabbed you. Imagine the school
lawsuits,
paperwork.
insurance.
Oh, it's just no. There's something. Sorry, I'm going to have to go to this. It's just we've got duct tape. So,
word of advice to anyone who's doing packaging: please don't use too much duct tape. It's. I know you're trying to be safe and secure, but it's just not easy to open.
It's over the top, isn't it? It's a bit much. It's a bit much. Yeah.
Just so you know.
Handy tip there. Thanks, Ryan. All right.
Bubble wrap.
We love popping bubble wrap.
Oh, yeah.
Ooh. Yep, Jacob. He's a first-year electronics engineering student. Slovakia. Wow. He's studying in the UK, though. There you go. It's an international world.
Sweet.
And he's an electronics hobbyist. Let's see what Jacob sent in. More bubble wrap. More nuggets. There we go, pop that.
Yeah.
The joys of therapeutic, isn't it?
Yeah.
Love it. Let's go. What do we got?
Really so much stress by doing this all day.
Is school stressful these days? Is high school stressful?
A little bit.
Yeah.
It probably gets even more stressful when you get to year 11, since I'm in year 10 right now, but, you get through it.
Yep, you survive. It's all a matter of survival, high school, isn't it? It's pretty much, until you're free.
Survival from schoolwork, survival from bullies,
yeah,
all that stuff.
Yep. Whoa, it's a cable simulator. Woohoo! Check it out. Whoop. There we go. And it's for simulating, I guess, based on the symbols, twisted pair cable, 300 kilohertz, ISDN bandwidth, and all that sort of jazz. So, yeah, really old school. Everything's fibre these days. They're not running, geez, even I've got fibre in the lab here. Well, not fibre to the lab. I've still got twisted pair coming from the MDF room down the bottom up to here. So, we still use copper. Ryan just called me a grandpa.
Yeah, the way you were looking at those magazines, you're pretty much a grandpa.
Yeah, young bloody whippersnappers, I don't know. Anyway, Jacob, with a K, has sent in this cable simulator. I haven't seen it before. It's a 5260, a division of... It comes from... Oh, geez, your logo's all tucked away up in there. How do you expect people to know your product if it's tucked away? Processing Telecom Technologies, a division of Adra or something like that. Anyway,
Adiron, I believe.
Adiron. Okay,
Adiron.
there we go. So what we can do is just switch in the different distances here, and I believe these are feet. So you can, whack in 500 feet and stuff like that, and you've got access to the rear panels at the bottom. It's showing that up to 10,000 feet here, 300 kilohertz bandwidth and 100 kilohertz bandwidth if you want to go, well, if you want to include like all of them, so you can, if you put them all on, that's your maximum length, I believe. I love how these switch in the little eye like that. It's just like they really stand out, really good. Nobody does those anymore. I love those. Those indicators, they're just terrific.
It just makes it feel like it's more alive that
It's
way.
alive, yeah, kind of, like sort of, the dinosaur, Pleo, right? He's got little eyes and he opens up and...
Wake up! Wake up! We need power!
It's like Hal. I'm sorry, Dave, I can't do that. All right, 2-minute teardown. And that's, oh, holy goodness. Look at that.
That's a lot of yellow.
Crikey. USA, 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 land of the tantalum capacitor. Except, no, because Australia has the largest tantalum mines in the world, I believe. Sorry, Yanks. Now, you may be wondering what's going on here, and I think I have an idea, because I've done cable simulation in the past. As you know, I worked on big, 10-kilometre long seismic arrays and things like that. And what I believe they're doing here is this is, like, as it says, it's a cable simulator. So what they've got is they will actually join all these elements. They would break up you'd simulate the cable into all these discrete elements in series like this. So, RLC, because every cable has DC resistance, of course, so you've got to have some resistance in there. Each cable has some inductance, so you've got to have some inductance in there, and each cable has capacitance, of course, so you've got to include that. And the way you simulate it in length is to break it down into little elements and join them all in series like that. And you snake it around and you can simulate your long cable line. So let's see if we can see that happen in here. You can see that this is sort of going in here and then going to the next array, which then goes to the next one and then goes to the next, and there we go, in series, and then goes to the next one. Boom, 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 like that, and all the way along. Now this is fascinating. I was wrong about these being tantalums. That just, like, I opened the thing and there were tantalum-looking devices. But of course, Dale do not make tantalum capacitors. And I thought they were a little bit sort of too short and stubby and high to sort of be tantalums, but they looked like tantalums for all the world, but they're not. Look, 10R8. And you might think that's a resistor, but I suspect that is not. I suspect that puppy's an inductor. And what these little MILF packages here you thought might have been inductors, well, they are. I mean, there's a couple of little tiny, but you can see them. You can see the turns on there. So are they like a spiral cut MILF resistors / tiny inductors? I believe these are inductors, and these puppies are little resistors, like very low value resistors. And of course we have our multi-layer ceramic caps here, but yeah, that's just sort of back to front to what you initially would have thought when you first glance at this thing. It's interesting to note that we've got different configurations for these lumped elements here too. This one, for example, has these two 10.8 microhenry inductors here in parallel, and then in parallel with these two other spiral cut resistors. You can see the traces all paralleled up. But this one here, this will just be a single, look, that's just the inductor on its own, and then we've got the two resistors in parallel, another inductor on its own. So yeah, it's certainly all over the shop, different configurations. They're tweaking it to get exactly the simulation that they want. And then under these two top boards, we've got another one in the opposite direction, which is very similar, but slightly different. We've got, once again, Dale inductors there, but they're black instead of a very confusing tantalum-like yellow. And then under there, we've got more arrays. Look at them. Wow. As far as the eye can see. Unbelievable. So there's 1, 2, 3, and then there's a fourth, which is another one of these puppies down on the bottom layer. Unbelievable. And it turns out this puppy can simulate up to 60,000 feet for you Yanks, up to 100 kilohertz bandwidth, or 20,000 feet up to 300 kilohertz bandwidth. And of course, you just switch them in. It's a complete passive RLC network array, and that's all it is. You can switch the thing in, and there you go. Simple cable simulator. But that's, yeah, I've done these sorts of things before, and you just break them down into the individual RLC elements so that you can simulate a cable as a lumped element array of RLC all the way down the cable. And here's the basic DaveCAD model of what I'm talking about. These lumped elements here, you can actually simulate any length cable. This is just a simplistic way to do it, just a simple RLC, and you can get in there and like put them in the bottom, and edge, capacitors aren't ideal and inductors aren't ideal, blah, blah, blah. But, basically you can simulate a long cable line just with a lumped element array like that. So thank you very much, Jacob, for sending that in. We haven't seen one of these before on the blog, and they are fascinating and essential tools for simulating lines. And people will actually take this as a portable, and you take it out in the field, of course, and it's completely passive, and you can hook the thing, there you go, you can hook the thing up, and you can do cable simulations out in the field when you're doing installs, and then nothing takes its place. I mean, you can't carry around a 60,000 foot reel of cable to do your simulation on. So these are actually quite a decent way to do it. So thank you very much, Jacob. Fascinating. Next up, we've got one from China, but it's not your typical Chinese product. It's from Peter, who clued me up on this. Thank you very much, Peter. We've got straps and all sorts of things on this. From Siemens, and of course, Siemens do tons of industrial stuff. So this will make an interesting teardown, I suspect. So probably be more than a 2-minute teardown. And we got
use that man strength.
There we go, nerd strength. All right, and these are, if you're into your industrial motor controllers, inverters, things like that, it's a Siemens inverter. So these are fascinating devices, like real high-powered stuff. You know, driving big motors and things like that need lots of high currents. And these are apparently, Peter assures me, real nice. That's a, yeah, it's a nice, it's a Dynamix V20 industrial motor inverter controller thing. So these will make fascinating teardowns. There's lots of technology that goes into these puppies.
You know something that with all these danger signs, it's gotta be good.
It's got to be nasty, yeah. It's going to get hot and it's all high voltage, blah, 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 or exclamation mark. Yep, what's that? We've got a little plug on the front. Don't know what plugs in there.
It seems to be a safety thing, because you know how metal can get in there? It's like, that's to protect it.
Oh, yeah, the little plug, yeah. If you've got an industrial environment, you want to keep that little plug on there until it's probably like a little programming port or something, maybe. So, yeah, fantastic. Thanks, Peter. These are going to make for a great teardown. And we've got a second one here, and you were telling me about Nintendo 64s. Yeah. About my Nintendo 64 teardown. Tell us about the story there. What's the history?
Yeah, apparently, when it came to the Nintendo 64, I didn't know this myself until I watched AVGN. When there was this company called Wisdom Tree, who was making these Bible adventure games for the original Nintendo systems. So when Nintendo realized this, when they made the Nintendo 64, they made a lockout chip in the Nintendo 64 to stop it from happening again. And the only games that would allow the Nintendo 64 are games licensed by Nintendo. However, Wisdom Tree did find a way to override it when it was a game called Supernova's Arc 3D, where they made a deal with id, where apparently id was annoyed with Nintendo because Nintendo had toned down the violence in Wolfenstein 3D. So to get back at them, they handed the design and software and stuff for Wolfenstein 3D over to Wisdom Tree, and they made the mockery known as Supernova's Arc. And in order to override the system, they actually made the cartridge so that you plugged it in first, and there was like this slot on top where another game could be inserted. You would insert a Nintendo, a licensed Nintendo game on top, and that would override the lockout chip.
Got it. There you go.
They were some clever cards.
Yeah. I didn't know ID did stuff that was on the Nintendo. I thought they were PC games only.
Yeah, I think it was. I think it was for some other system, but I think I'm not sure how Nintendo got involved in some way. I would have to do more research on it.
Fascinating. Is that what you want to get into? Maybe gaming videos or something?
I do.
Retro games?
Well, not retro.
Well, retro to you, not retro to me. Retro to me is 80s. Right.
Yeah.
Retro to you is what, 2000s?
Yeah, somewhere like 10 years ago. Right. 1990s to 2000s.
Yep. Cool. Another gaming channel coming up. Check out Ryan's. Well, you don't have a channel yet, do you?
I'm hoping to make one.
We'll link it in when he does. Awesome. And we've got ourselves another controller. Oh, that looks jazzier. Look at that. There we go. That's spunky. Nice big heatsink on the back. Awesome. Thanks, Peter. So thank you very much, Peter, for sending these puppies in. We're going to definitely do a separate teardown of these. Now, Peter made the point of explaining that they actually... these contain really advanced IGBT modules, like completely snotted in silicon, and really fabulous stuff like that. But more amazing than that, they actually model the behavior of the thermals of the IGBT transistors and stuff like that. They model those, and there's actually BGAs and things in here to actually do some advanced thermal and other modeling of the stuff that happens within these things, and that's how they get the efficiency in such a small package. And I think there's a lot more to these than what they look. Just not a bunch of just off-the-shelf components from DigiKey whacked in a nice case and whacked the Siemens label on it. There's a lot of advanced tech which goes into these high-power motor drive inverters. And they also model all the magnetics of the motors as well. So there's lots of BGAs in here, lots of processing grunt in here, which simulates the thermal behavior of not only the power semiconductor devices, but the motors that they're driving, all the magnetics and everything else. You can imagine what sort of, horsepower is required to do that sort of modeling. So it's all done inside here. That's how they get the efficiencies inside these things. And they can have, I guess, relatively small heat sinks. I'm not sure about the actual performance of these things. 0.33 horsepower motor for this puppy here. Anyway, apparently really advanced tech in here. So it could be fascinating to take it apart, and if I can get any more technical info on how they do that modeling and stuff like that, we'll definitely include that in a follow-up teardown. Thank you very much, Peter. So thank you very much, everyone who sent in stuff to Mailbag, and thank you very much for Ryan for helping out. He's here all week, folks. He's here all week. Awesome. And hopefully you'll maybe be assembling some of the pick and place machines. Maybe. Perhaps.
Sounds like fun.
We'll see. Awesome. Catch you next time.
You are a dork. It's tough being a work experience kid, but in the end, it makes you productive.